Blueprint to campus, monoliths versus microservices. Welcome to The Explainer. Listen up, junior devs, because today we are treating software architecture like physical city planning. We're plunging straight into the architectural blueprints to visualize exactly how we build digital infrastructure. Let's just dive right in.
Okay, so we're starting with the monolith. Think of this as a massive, incredibly dense, towering skyscraper. Literally every single component, your authentication, your UI, the database, it's all just crammed into one logical executable. It's this tight, totally self-contained code base, which is actually exactly how Uber built their very first architecture.
The magic number here is 1. You've got one code base, one deployment, and one server environment. And honestly, startups absolutely love this single skyscraper approach. Why? Because it requires way less upfront planning and gives you incredible speed to market. You basically just write code and stack floors.
But here's the massive catch. Fast initial build versus rigid scaling constraints. While that single skyscraper goes up incredibly fast, it creates a tightly coupled trap. As your user base starts to grow, trying to modify or scale that one giant building, it becomes an absolute nightmare.
If you dive into the dense plumbing of a monolithic system, you can practically feel the bottlenecks pulsing under the stress. This is exactly what a system looks like sitting right at its breaking point.
Because everything is so tightly coupled, a tiny issue just cascades. Imagine a single broken pipe, maybe a seemingly harmless little bug in your billing code. Because it's all one building, that burst pipe literally floods the entire skyscraper. Billing fails, the UI crashes, and suddenly the whole app goes down.
So your crucial metric here is actually 0. That's your fault tolerance. In a monolithic architecture, a fatal mistake in just one feature brings down all the servers. You're dealing with a massive single point of failure.
Furthermore, consider the ultimate scaling flaw. Let's say your billing department gets slammed with heavy traffic. You can't just expand the building floor, right? Instead, you are forced to duplicate the entire massive skyscraper across new servers just to handle the load. It is a massive waste of memory and compute.
So, what's the fix? Well, we semantically shatter that monolithic skyscraper. We zoom out and reveal a beautiful, highly organized, sprawling campus made of smaller, specialized buildings. Welcome to the microservices solution.
Microservices fundamentally decompose the application into small, independent services. In our new city grid, each cross-functional team gets its own dedicated building. So you've got one building strictly for Auth, another completely separate one for users, and a different one entirely for billing.
Picture data packets moving fluidly through this campus. They all start at the API gateway, which is basically our digital traffic controller. And it intelligently routes requests via lightweight APIs directly to the specific service buildings that actually need them.
But this setup requires a complete data revolution. Instead of every department fighting over one massive, slow basement vault, we shift to polyglot persistence. Every single building on the campus gets its own independent database, perfectly optimized for its specific type of data.
And remember that flooded skyscraper from earlier? Well, in a microservices campus, we isolate the failure. If a bad code push causes the billing building to catch fire and go completely offline, the rest of the campus, things like user search or chat, they stay perfectly operational. Your app doesn't die.
But listen to me closely here. It is time for a serious reality check. You might look at this sprawling campus and think it's just pure magic. It's not. It comes with a heavy operational cost, and we call that the complexity trade-off.
Think about it. In the old skyscraper, services talked using blazing fast in-memory function calls. But now, they have to communicate across a sprawling campus. That requires complex API highway systems, which introduces network latency, potential packet loss, and just immense architectural complexity.
Which brings us to a very specific number, 3, as in 3 a.m. Debugging a traffic jam across a bunch of loosely coupled buildings requires highly advanced observability and tracing. Because without automated monitoring infrastructure, those 3 a.m. pager alerts are going to completely destroy your team's sanity.
So we arrive at the ultimate architectural rule of thumb from software pioneer Martin Fowler. He says, start with a monolith to validate, break into microservices to scale. Basically, build the skyscraper first to prove your business actually works, and then call in the city planners only when your traffic demands it. Which leaves a final, pretty provocative question for you to take back to your desk. Take a hard look at your current code base and ask yourself,
Are you building a simple prototype to hit the market tomorrow, or are you engineering the scale of the next Netflix? You got to choose your city plan wisely.